Okay, today we're going to start with 4.1, our study of right triangle trigonometry. We're just going to really just kind of start with being able to sides of a right triangle. For that, we can use the Pythagorean theorem, which says that a squared plus b squared is equal to c squared. This will only work for right triangles, and the c here represents the hypotenuse of the right triangle. So the hypotenuse is always going to be directly across from that right angle. That's the missing piece for us right now. So in order to solve for that missing side, we would say x squared is equal to 2 squared plus 6 squared. We get x squared is equal to 40. So x would wind up being 2 square roots of 10. We only take the positive root here because we are looking for a distance, and that must be positive. For example 2 here, I've been given the b. They're telling me the c side is 4. So 4 squared is equal to a squared, that's my unknown at this case, plus square root of 6 squared. This will be 16 is equal to a squared. When you square a square root, just the number inside, the radicand comes out. We get a squared equal to 10, so a is equal to root 10. We're also going to be talking about some of our basic right triangle trig. You probably remember from geometry class this SOHCAHTOA over here. S stands for sine, and the ratio is opposite over hypotenuse. C stands for cosine, the ratio is adjacent over hypotenuse. T stands for tangent, which is opposite over the adjacent. You'll be noticing this symbol a lot right here during our study of trig, and that is the Greek symbol theta. We use that often to represent an angle. We can use other letters, but that's just something that we see. When we're talking about a right triangle, and we're talking about a particular angle, x like this. So the first thing, the hypotenuse is always the hypotenuse. So it's directly across from the right angle. The adjacent and opposite sides can switch though. So if I'm looking at this angle here, the opposite side is the one that is directly across, so that would be side A in this case. The adjacent side will be touching the angle, so that would be B. If by chance we were looking at this angle here, and I'll just call that one theta, then this then would become the opposite side, and this would become the adjacent side. So it just depends on which angle that we're talking about. There's a total of 6 trigonometric functions here. So we have sine, cosine, and tangent. Those are the ones we're going to be working with today. These are the ones that we're going to be most familiar with. We learned about those in geometry class. But we also have these other ones, which are cosecant, secant, and cotangent. And what those are just the reciprocals of these trig functions here. I always kind of remember that the c and the s's match up. So sine is its reciprocal is cosine. Cosine, its reciprocal is secant. Tangent, the reciprocal is cotangent. We're going to be looking to solve right triangles. In order to do that, we need to find all the angles and all the sides. We can use Pythagorean theorem, use the fact that triangles sum to be 180 degrees, the 3 angles, and we could also use SOHCAHTOA to help us. We may be seeing some letters. Angles are denoted by capital letters here. You may see the Greek versions of them. So we got lambda and alpha and beta. So we can use those as well for the angles. Sides are denoted by lowercase letters. The sides are going to be directly across from the angle. So this would be side A. This would be side B. This guy would be side C. Here's our right angle, so this is definitely our hypotenuse here. Okay, so it's telling us that angle B is 65 degrees, and that side A is 14, and they want us to find the missing pieces. The easiest piece to find here is this angle A. All triangles sum to be 180 degrees. So 180 minus 90 minus 65 would get us a 25 degree there. Now I need to find the 2 sides. So I'm going to start with A here. I'm going to use the 65 degree angle. Whenever you're doing your trig functions, it has to be one of the 2 acute angles here. You cannot use the right triangle. And I like to, if I can, use the one that was given in case I make some kind of arithmetic mistake finding the second one. So from here, I'm looking to find side B over here. So across from the 65, that's the opposite side. This is the adjacent, the side that I know here. So that is going to be the tangent. So the tangent of 65 is going to be the opposite side of B over the adjacent side of 14. Using our cross products here, we're going to get b is equal to 14 times the tangent of 65. At this point, you can use your calculators. If you're using the TI-84, definitely go to the mode button and make sure that you're in degrees and not in radians. If you have any trouble with that, ask your teacher. And I did not get an answer for that on my calculator. So if I want 14 times the tangent of 65 here, so let's see, 14, I gotta put my degree, okay, I'm gonna quit there. Alright, so 14 times the tangent of 65, you should be getting about 30.02, and we'll go ahead and round to the hundredths here. Now I want to find the hypotenuse. I could use Pythagorean theorem if I want to. I'm going to stick with the trig functions. So now, again, I was given the adjacent side, and now I'm looking for the hypotenuse, so that would bring us to cosine. So the cosine of 65 degrees would equal the adjacent side of 14 over the hypotenuse, which is what I'm looking for here. If the variable's in the denominator, what you're going to do is just switch these two functions to solve. I kind of remember that because denominator starts with d, and when I switch, we're going to wind up with a division. And if you put that into a calculator, you would get 14 divided by the cosine of 65, and that would get us about 33.13. Okay, so let's flip our papers over. Here's one of the problems. We're just looking at the Greek letters in here. Our right angle is sitting here. So it's telling me if C is 12 and alpha is 40, they want us to find the rest of the triangle. So again, triangle sum to be 180 degrees. That would make beta to be 50 degrees. I'm going to use the cosine. I'm going to use this 40 degrees again, so that's the one that was given. Let's find A first. So from this angle, that's the opposite side, and I know the hypotenuse. So opposite and the hypotenuse, that will bring us to sine. So I know that the sine of 40 degrees is going to equal the opposite side A over the side, which is the hypotenuse, which is 12, not 40. So A over 12. Again, my variable's in the numerator, so that means we just use our cross products here. So A is going to equal 12 times the sine of 40, and that turns out to be about 7.71. Now I'm going to look for B from this angle here. Now I'm dealing with the adjacent side and the hypotenuse, so that would be cosine. So the cosine of 40 degrees is going to be B over 12. Again, I'm in the numerator there, so I'm just going to multiply these two numbers together. So B is going to equal 12 times the cosine of 40, and that turned out to be about 9.19. Alright, so that's how you solve a triangle. You need to get all three angles and all three sides. We're going to be doing some word problems with this right triangle trig. The first thing we need to get is some terms down. The angle of elevation is from the horizontal and an angle going upwards. So whatever that angle would be the angle of elevation. If we talk about an angle of depression, again, if we're up here, there's the horizontal. It's the angle formed by looking downward. All right, so let's try a couple of these word problems. Okay, so I got a person standing on top of a 40-foot building. That's tall and sights a friend on the ground. The angle of depression, so there's the friend on the ground. The angle of depression is 52 degrees. How far is the friend from the base of the building? Okay, so I got my right triangle here, so that's going to make the hypotenuse sitting over here. What we're looking for is the distance here. What I have is the angle of depression is not inside the triangle looking for, but what we got are two parallel lines being cut by a transversal, causing these to be alternate interior angles which are congruent. Okay, so I'm going to use this 52-degree angle here. This is the adjacent side. I know the opposite. If it's adjacent and opposite, that's a tangent function. So the tangent of 52 degrees is going to equal the opposite, which I know is 40, over the adjacent, what I'm looking for. Again, that variable is in the denominator. So denominator starts with D, divide starts with D. We're going to do the switch here. X is equal to 40 over the tangent of 52. And then when put into a calculator, that turns out to be about 31.25 feet away. Okay, let's try another one. So we've got, moving down here, a point 100 feet from the base of a building. All right, so there's the building at a point 100 feet away, so that's what they're referring to, the bottom part there. The angle of elevation to the bottom of a smokestack. So there's the building. It's got like this little smokestack on top here would be, what did they say that was? 37 degrees. And if I'm looking for the angle to the top of the smokestack, they're telling me that is 42 degrees. So that bigger angle is 42 degrees. And they want to know what is the height of the smokestack. So what I'm going to do is first find the height of the building here. I'm just going to call that X. Then I'm going to find the height from the ground to the top of the smokestack, which we'll call Y. Then I can subtract these two to get the height. I know the adjacent side. Both of these are the opposite sides. I'm going to be using the tangent function for both. So I know the tangent of 37 is going to be equal to the height of the building over 100. Variables in the numerator, we're just going to multiply these two. X is equal to 100 times the tangent of 37. That turned out to be about 75.36. Now I'm going to solve this Y from the ground to the top of the smokestack. Again, it's still opposite and adjacent, so I'm still using tangent. The thing that changes now is the degree, which we're going to use 42, is equal to Y over 100. Again, we're going to use our cross products here. And that turned out to be about 90.04. Then to get the height of the smokestack, we're going to subtract these two numbers, and you get about 14.68 feet. Okay, we've got one more problem to do. Find the angle of ascent. Now this time we're looking for the angle for a plane that flies at 275 feet per second for 1 minute if its altitude increases to 9,000 feet. So we're starting on the ground. You got the airplane going up. It's increasing to 9,000 feet. If it's going 275 feet per second for 1 minute, we have to multiply this by 60 here. And what we get is 16,500. And what they're looking for is that angle of elevation there, theta. If we're looking for angles, you're going to need to use the inverse functions on your calculators. It's when you hit second tangent, second cosine, second sine. Get any calculator questions, please ask your teacher. So I'm going to use, let's figure out which of the trig functions we need. I have the opposite side and I know the hypotenuse. So opposite and hypotenuse is a sine function. And again, I'm going to use the inverse function when looking for an angle. So that's going to be 9,000 over 16,500. You put that in the calculator, I got an angle of about 33.06 degrees. All right, and that concludes our lesson on right triangle trig.